Hello friends, welcome back to our channel.
So today we are discussing the CBSE class 12th chemistry question paper 2026. So we are discussing the first set. So first what you have to do, we will go into the Google Chrome and then we will search for the cbseboardonline.com, cbseboardonline.com. So here we go, CBSE board. We will go into the class 12 tab. Here we are having the ad. So class 12th question paper, final exam paper. Then we will have the paper of chemistry. We will search for the chemistry subject here. This is the first set we are going to solve. Okay, so first we will download this paper. And first section A, oxidation of chloroform by air in the presence of sunlight produces a poisonous gas known as. So first is mustard, second is tear gas, third is chlorine, fourth is phosgene. So the option is phosgene, D. So कैसे phosgene, इसकी रिएक्शन देखते हैं. देखिए 2CHCl3 प्लस O2. CHCl3 मतलब क्लोरोफॉर्म. जब इसको हम ऑक्सीडाइज करेंगे, इट विल undergo oxidation in the presence of sunlight and air, so it will give the carbonyl chloride, जिसको आप phosgene भी कहते हैं, that is COCl2 plus hydrochloric acid. So when the CHCl3, that is the chloroform, is reacted with oxygen in the presence of sunlight, it will give the phosgene. Okay, so the answer is D, phosgene. Lucas reagent produces cloudiness immediately with 2-methyl-1-propanol, butane-2-ol, 2-methyl-2-propanol and butane-1-ol. अगर हम ल्यूकास रिएजेंट की बात करें तो व्हाट इज ल्यूकास रिएजेंट? कंसंट्रेटेड HCl और anhydrous ZnCl2 is Lucas reagent. Answer is C, 2-methyl-2-propanol, because Lucas reagent is used to distinguish between the primary, secondary and tertiary alcohols. So tertiary alcohol react immediately to form the insoluble alkyl chlorides. So that is 2-methyl-2-propanol is a tertiary alcohol. So it produces cloudiness immediately. Okay. Which of the following d orbital experience more repulsion in the crystal field? Splitting of octahedral complex. So B is the right answer. So how B is the right answer? So in an octahedral complex, the 6 ligands approach the central metal ion directly along the coordinate axis x, y and z, and the lobes of the orbitals dx square, y square, x square minus y square and z square point directly along these axes, causing them to experience greater repulsion from the ligands. So B is the right answer. Fourth is the chelating ligand used for the treatment of lead poisoning is. So it is EDTA, that is the ethyl diamine tetraacetate, that is EDTA. It is a polydentate chelating ligand. In the treatment of lead poisoning, a solution of calcium disodium EDTA is administered, and the lead ion displaces calcium because lead forms a much more stable, non-toxic soluble chelate complex with EDTA, which is easily excreted by the body in the urine. Okay, so the answer is D. Manganate ion is paramagnetic due to the presence of. So manganate ion is paramagnetic due to the presence of one unpaired electron. So the chemical formula of manganate is MnO4 2-. So we will calculate the answer. So there is one unpaired electron in the 3D subcell. The ion is paramagnetic. Okay. The correct order of decreasing basicities. What is the decreasing basicities of these particular chemical compounds? So the basicity is, in an aqueous solution, the basic strength of substituted amines, these are all amines, is determined by the combined interplay of 3 factors: the inductive effect, the steric hindrance and the hydration energy. So for ethyl substituted amines, the balance of these factors yields a basic strength. So that is the secondary, first then the tertiary, then the primary. So which corresponds to this particular secondary alcohol, then that is tertiary, then the primary. Okay. The boiling point of 7th question, 1 molar NaCl solution, assuming NaCl to be completely dissociated in water is, so the Kb for water is 0.52 kg per mole. So the boiling point will be 101.04 Celsius, that is the B. So what is the explanation? Using the elevation of boiling point formula, the delta TB is I into Kb into M, so that is this. So we will get, since the boiling point of pure water is 100 degrees Celsius, the boiling point of the solution is 101.04. Okay. When a liquid and its vapor are at equilibrium and the pressure is suddenly decreased, what will happen? The cooling appears. How? C is the right answer here. When the external pressure is suddenly lowered, the equilibrium is disrupted. To re-establish the equilibrium state at the new lower pressure, the liquid undergoes rapid spontaneous vaporization. So vaporization is an endothermic transition. So liquid draws the required latent heat from its own internal thermal energy, which result in drop in temperature, that is the cooling occurs. 9th question is, consider the following cell at 298 K. How can we increase the EMF of the cell using the same substance? According to the Nernst equation for this specific cell setup, this is the Nernst equation. To maximize the E cell, we need to make the value of the log term as small as possible, and this can be mathematically achieved either by decreasing the concentration of the products Mg or by increasing the concentration of the reactants. Hence, lowering Mg to 0.1 increases the cell EMF. So the answer is A, by decreasing the Mg ion Mg to 0.1 M. Okay. The rate of first order reaction is 5.6 into 10 to the power minus mole. When the concentration of reactant is 0.2 per mole, the rate constant K is, so rate is equal to K reactant, substitution the given parameters into the formula. The rate is 5.6 into 10 to the power 4, K into 0.2. So the K rate constant K will be 2.8 into 10 to the power minus 3. Okay. Nucleic acid are the polymers of nucleotides or nucleosides. It's nucleotides, that is C. Nucleic acids like DNA and RNA are the bipolymers made up of long structural chain of the repeating monomeric units called nucleotides. So each individual nucleotides is comprised of 3 parts: a pentose sugar backbone, a nitrogenous base, and a phosphate group. So the answer is C. In the reaction of NaOBr with amide, the carbonyl carbon is lost as, it will be lost as CO3 negative. The chemical treatment of aliphatic or aromatic amide with NaOBr is known as Hofmann bromide degradation reaction. So in this mechanism, the original carbonyl group of the primary amide is explicitly cleaved and expelled into the strongly alkaline reaction in the form of soluble carbonate ion. Okay. So now next question, assertion based question, 13th question. Alcohols act as Bronsted bases as well as Bronsted acids. So what is the reason? It is due to the presence of unshared electron pairs on oxygen atom and presence of polar OH bonds. So both are true, and reason R is the correct explanation because alcohols are amphoteric. They can act as Bronsted acids because of highly polar OH bonds, and easily donate a proton to a strong base. So conversely, they can behave as Bronsted bases because of the lone pairs residing on the oxygen atoms. Okay, so this is the right statement. Diazonium salts of aromatic amines are more stable than those of aliphatic amines, and diazonium salts of aliphatic amines undergo resonance. The assertion is correct, but the reason is false because the aromatic diazonium salts are relatively stable at low temperature, and because the positive charge on the diazonium group is dispersed into the benzene ring via resonance. However, the reason is completely false because aliphatic diazonium salts cannot undergo resonance stabilization. Okay. 15. For complex reaction, order of reaction is given by slowest step. Order of reaction is an experimental quantity. So both the assertion and reason are false. Reason R is not the correct explanation of the assertion. Both assertion and reason are true, but reason R is not the correct explanation because both the statements are true. Okay. For any multi-step chemical reaction mechanism, the slowest step dictates the net speed and acts as the rate determining step, which determines the overall reaction order. So it is true that the reaction order is fundamentally an experimental parameter that cannot be deduced simply from a balanced equation. And 16th, here E0 has low value because the stability of Sc3 plus ion, which has noble gas configuration. So both assertion and reason are true, and reason R is the correct explanation. Scandium has the ground state configuration. When it loses 3 electrons to form Sc3 plus, it achieves the highly stable electronic configuration. So Sc3 plus is immensely stable. It resists being reduced back to Sc2 plus. Okay, so making the reason a valid and a direct explanation. So that's all for this set. Have a good day, and we will be back with the next set. So तब तक के लिए आप A to Z सब्जेक्ट को लाइक करें, सब्सक्राइब करें और शेयर करें. Thank you very much.